Hello friends and welcome to Edupedia World Videos. This is the course Basics of Programming in C language, and right now we are doing some practical exercises on pointers. Okay, so till now we have covered various practicals on pointers, including some theory on pointers. And in this particular video what we will be doing is we will be learning about pointer arithmetic. So what is the difference in normal arithmetic and in pointer arithmetic? Well, one obvious difference is obviously that pointer arithmetic involves addition or subtraction or arithmetic operations on pointers. Okay, and in normal arithmetic we straight away deal with the variable values. Okay, but how is addition, subtraction, or any arithmetic operation on pointers different from the arithmetic operation on normal values? Well, in pointers, but we know that a pointer is a variable that stores the address of memory location of some other variable. So here when we increment and decrement, instead of doing this in numbers, it does it in memory locations. Okay, so it does not matter, there is no difference if the size of the data type of the pointer is 1. For example, in char pointers, the data type char has size 1. Okay, so if you do some addition, subtraction on char pointers, it will be same as doing that on some values. But for data types like integer, where the size of the data type is 4, now if you do an arithmetic operation on an integer pointer, so if you increment an integer pointer, it will not increment by one number, but it will get incremented by one memory location of the integer data type. So one memory location of integer data type is equal to 4 bytes, because an integer is stored in 4 bytes inside a memory of the computer. Okay, so when you increment it, it will get incremented by 4. Similarly, for short data type, short int, the size of a short int data type is 2 bytes. So when you increment or decrement a short int pointer, it will get incremented or decremented by 2 memory locations. So let us now verify this programmatically. First, what we will do is we will just declare 3 arrays. First would be the character array. So let me name it as char array, and the size would be 10. And inside this char array, I will be storing 10 characters. Okay, so this is how you can initialize an array. While initializing, that is how you have to do. Okay, so let me now copy this so that I will just replace the values further. Okay, so now we have exactly 10 values initialized in this particular char array, and for the next data type we will be using a short int variable. So let me name it as short array. The size would be 10, and now I will be initializing with 10 numbers. Okay, 0. So this is 10 numbers which have been initialized in a short int array. Similarly, in an integer array also I will be initializing 10 numbers. So I will be naming it as int array instead of short array. Okay, so three arrays have been declared. One is char array, another one is short array, and another one is int array. Now for reference, let me just print the data types of each of these variables, the size of the data types of each of these variables. Size of, so the syntax of a printf statement is what? First I have the constant string, inside it I will have to include some format specifier in case I want to print the value of a variable, and that variable name will come after the constant string after a comma. Okay, so right now I'm printing a size of a variable. So size is a numeric value, so it will be of an integer data type, and the integer data type has a format specifier %d. Okay, so size of, let us say, char will be printed over here is equal to %d. Okay, and this is nothing but a escape sequence, and escape sequences in C language are used for printing the non-readable characters like new line, white space. These characters which are not otherwise readable are made readable using escape sequences. So it will not appear in the output. In output, only a new line will be added at its position. So to know more about escape sequences and format specifiers, what you can do is you can watch our video tutorial on the console input and output. Okay, here I will be writing size of and char. So size of operator we have done, and what does it do? It just gives the size of a variable or a data type whichever is passed inside it. So here I can replace it by short int, and similarly here I can write int. Okay, so let us first try and execute this much of our code. Okay, it has printed size of char is 1, size of short int is 2, and size of int is 4. So that we have already discussed. Okay, now what we will do is we'll try and increment or decrement the arrays, the pointers of character, integer, and short integer data type, and let us see their values. So first let us just print them as it is. So let me print char array. So we have always discussed that the array name in itself is a pointer to the 0th memory location of that array. We can also verify that. Okay, so let us verify this. So how can we verify it? It will just be sufficient to verify when we will print char array and address of char array index 0. Both should be same. So if both are same, that means that the array name in itself is the pointer to first location or 0th index of the array. Okay, so char array, and this I will be printing equal to %d. Why? Because memory locations are nothing but numeric values. Okay, so it will be printed using an format specifier for integer, which is %d. So char array, and then char array 0. So this is the address of char array 0 is equal to %d. So char array and address of char array 0. Okay, so that is how it will get printed. Sorry. So now let me just explain you this statement, what it does. This %d will be replaced by char array. So what value is inside char array? It is an array. It is not a variable simply. So it will not print any value, but it is an array name. So it will print the address of first memory location, okay, which is 0th index. And here we have used an address of operator. Okay, address of operator is the ampersand inside C language, and whenever it is placed behind any variable name, it is known as address of operator. So it will calculate the address of memory location of this variable, and the variable over here that we have used is char array index 0. So that would be the 0th index of this array. So what we are trying to prove over here is that array name is the pointer to 0th index of an array. If these two values are equal, that means our assumption or our learning is correct. Let me just compile this code and if it has compiled successfully, then yes, it has compiled successfully. Only warnings have been issued. The warnings are because we are not using these variables anywhere. So compiler is trying to warn us that okay, you have declared these variables, they are occupying some memory, but you have not used them anywhere. So we know that we are in the process of completing our code. It is not yet completed. So we will be using these variables later on. So we are not doing anything about it. Okay, so over here we have printed char array. The address is 2686726. Similarly, the address of char array 0 is 2686726. So the value inside char array, the array name, is also the address of first zeroth index of char array. So our assumption is true. Okay. So now what we have to do is we will try and increment this value by 1 and then print it. So what I will be printing now is char array plus 1 plus 1. That is how we will print char array plus 1, and over here we'll try and print index 1, address of index 1. So if these both values are equal, that means that pointer arithmetic actually increments the addresses, okay, instead of numbers. So what we have to do is we just include some new lines over here so that the output is clear over here, right? So it is char array plus 1 we have printed. It is 2686727, and similarly the location of the first index, we have forgotten to replace this 0 by 1, although this is just in the constant string, so it will not impact the execution of the program, but it will impact the output that is displayed on the screen. Okay, so now it is saying char array plus 1 is and address of char array index 1. So these both are same. Okay, so that means that char array plus 1, when we did this, it incremented the pointer by one memory location. Okay, but how do we know it's true? It is incrementing by one memory location only, or just by one number? So that we will come to know when we will do the same thing for our other two data types, for shortint and integer. So we'll print two more uh, similar statements. We will add two more similar printf statements. So here instead of char, I will be having short. So just let me quickly replace these for you. Okay, so I'll just copy this so that I can replace it all over. Okay, so here, right, similarly I will do it for the int array. Right, so here the int array has also been replaced. Now let us see what the execution of this code results into. Now I'll just explain you a bit. So what we have done is we have done the same thing for short array and int array. So in int array also we have first printed the zeroth address of the zeroth index, and then what we have done is we have incremented the pointer by 1 over here. Okay, and we have printed the address of the first index. So if what we learned earlier is true, then here the addresses of both these things will be equal. So that means the value of short array plus 1 should be equal to the address of short array index 1. Similarly, the value of int array plus 1 should be equal to the address of int array index 1. Let us compile it and see the result. So I have compiled this code and I have executed it now. So let us see what result it produces. So let me just add a new line operator over here which got deleted by mistake. Okay, so here the result is over there. So for char array it is the same. For short array, let us see. So earlier the address was 2686706. Okay, for the first index. When we incremented it by 1, we incremented by 1 only. Okay, but it has incremented the same value by 2. Why? Because it is internally treating it as pointer arithmetic, so it is incrementing in terms of memory blocks and not in terms of integers, not in terms of numbers. Similarly, for int array, 2686664 and then 2686668. Okay, so it has incremented by 4 values because the size of integer is 4. Size of integer is 4, and similarly an integer pointer is incremented by 4 when we increment it by 1. Okay, so that is how it happens in pointer arithmetics, and the same thing is verified over here, that index 0 had this address which is same to the name of the array, and index 1 had this address which is same as name of the array plus 1. Okay, so internally the compiler understands that when I have to increment a pointer by 1, when I have to add 1 to a pointer, it would be actually equal to 1 multiplied by the size of the data type of that pointer. So that is what is the value that it is going to add. So I hope that this small concept, although it is quite a complex concept to understand, was clear to you. So thanks for watching this tutorial and continue to watch the course Basics of Programming in C language. Thank you.